Okay, so let's go over slope-intercept form. So just a reminder, the M in slope-intercept stands for two different things, really. In general, it's the parameter rate of change. Or in this unit, when we're specifically talking about a graph, it's considered slope. And there's two different ways that we can, or a few ways, but two different ways we can think about it. Rate of change is change in y divided by change in x. Or again, when we talk about it on a graph, we talk about it as rise over run. I have this little friend that I like to use to help me know what kind of slope or what kind of line I have, depending on the sign of the slope. And his name is Mr. Slope Guy. We'll talk about what this and what this mean later, but what this I tells us is that if a line has a positive slope, it should be going in this direction. If a line has a negative slope, it should be heading in this direction. So Mr. Slope Guy is just really helpful to make sure that your lines are headed in the correct direction based off of their slopes. The parameter B means initial value in general. So it's always the initial value of the function. Or again, when you're talking about a graph, it's going to be the y-intercept. So every linear function written in slope-intercept form will always have the point 0, comma, whatever b is. So to graph linear functions, first you'll plot the y-intercept on the graph. So in this case, 1 is the y-intercept. So you'll notice 0, comma 1 is the first point that's plotted on this graph. Then you'll use the slope to plot additional points. So my slope is 2/3. So 2/3. 2 is how many I will rise. 3 is how many I will run from this original point. So you can see on this graph, I went up 2 boxes and over 3. And then I went up 2 over 3 to get this point as well. And again, Mr. Slope Guy tells me because my slope was positive, that my line should be going upwards like this. You could also get additional points by reversing the pattern. So instead of rising 2, running 3, you can go down 2 and backwards 3 to get a point on the line as well. So that's always an option to reverse the pattern. So for this one, our y-intercept is going to be 0, -2. And now my slope is -4. This doesn't have a denominator the way it's written, but any whole number will always have a denominator of 1. So my rise is -4, or you could think maybe going down 4. My run is 1. So if I think of Mr. Slope Guy again, because my slope is negative this time, I should be having a decreasing line. So I should be going down 4 over 1, down 4 over 1. Or I can reverse the pattern, go up 4 and backwards 1, up 4 and backwards 1. And then we will, oops, that point should be just a titch higher right there. We can connect the points with a line. Just adjust that a little bit. And put arrows on the end to show that this line is infinite. It goes on forever. So here, there is no y-intercept. So the y-intercept is really 0. My slope is 1/2. So I'm going to rise 1, run 2, up 1 over 2. Or reverse the pattern, down 1, back 2. Connect the points with a line and draw arrows on both ends. This one is going to start at 7. It has a slope of -6. So it's really going to be down 6 over 1, down 6 over 1. I can't really fit in the going backwards on this graph, so I'll just leave it at those points. Make sure I get my arrows on the end, and that's going to be my graph. So just to revisit our kind of domain and range ideas, domain for this function, linear functions get infinitely wide. So the domain will be all real numbers. They also are infinitely tall. So both domain and range are all real numbers. For this one, if I were to ask you where is it increasing and where is it decreasing, remember this person is always walking left to right. So if you were walking on this graph, you would forever be increasing. So this is an infinitely increasing graph and it's never decreasing. However, if I were going to do the positive and negative intervals, there is a split. This graph is below sea level. So let's do this color. This graph is in the negative. It's below the x-axis, starting at the x value of -infinity until I get to the x value of 0. So it's negative from -infinity to 0. And then it comes out of the water or comes above the x-axis to be positive, starting at the x value 0 for the remainder of the graph. So to positive infinity. Perfect. Now, sometimes, let's look at this next graph. We've kind of got the domain and range down. That's pretty easy. We know that this graph is never increasing and that it's always decreasing. But sometimes with the positive and negative, it can be a little tricky because we need to know, where does this line go underwater? I don't know, but I can calculate it because I know this point is happening where y is 0. The x-intercept occurs when y is 0. So let's take our function and let's put in 0 for y. Oops, -6x. Okay, so I'm putting y here as 0 because I want to know, when does the x-axis or the x-intercept occur? And then I could just solve. So I can subtract 7 from both sides and divide by -6. So at 7/6, so the y-intercept here is occurring at 7/6, which makes sense. It's a little bit past 1, so 1 to 6 is right there. So this graph was positive above sea level all the way back at -infinity, at the x value -infinity, until it got to the x value 7/6. And then it went under the water, so it went into the negative, starting at 7/6 and until the x value positive infinity. So 7/6 less than x less than infinity. So if you can't see the switching point, let me highlight it in yellow. Like here, we could see it switched from positive to negative at 0. If you can't see that point, then sometimes you may need to calculate that point algebraically by plugging in 0 for y. And let's just look at some word problems. So again, we know that the parameter m is the rate of change for a problem. And we always use the word per to describe a rate of change. Now, normally when we find the rate of change in a word problem, we need to be careful for the scale. So in this problem, if I were to find the rate of change, which I know is my change in y divided by my change in x. Looking at my change in y, the temperature dropped by -2. So that's my change in y. It went down. in 1 hour. So even though it's 2 boxes, the scale on the x-axis is it's going by half, right? 1 box is a half. So 2 boxes is actually an increase of 1 hour, a change in x of 1 hour. So your rate of change is -2. B is really easy. It's where you're starting. So if we were to put this in words, we would say the temperature decreases by 2 per hour, decreases by 2 per hour, and the temperature was 82 degrees to start. So let's try this here. So let's find M by calculating the rate of change. So my change in Y, I was at 50 and I went up to 150. So my change in Y was 100. My change in X, this box is worth just 1, so it's 1. So my rate of change is 100. So I would say my balance increased by $100 per deposit. And B, where it started, was 50. So I could say to start, I had $50 in my account. So slope is a rate of change. B is an initial value, and that's what that says in a word problem. So we're able to see it in the parameters M and B.